Okay, 4.1, polynomial and rational functions. We're on page 179 if you need to look at more examples. So first let's talk about a polynomial function. A polynomial function is written in the form f of x equals a sub n times x to the n power plus a sub n minus 1 times x to the n minus 1 power plus all the way down, whittled down to a sub 1 times x plus a sub 0. Now, the a sub n minus 1, etc., those are your coefficients, and those need to be real numbers, okay? So a is a real number, and n, those are your exponents, right? Your powers need to be non-negative integers, right? So non-negative, like whole numbers. Now, you need to notice that a polynomial function only has one variable, all right? So we're working with x in this example. They could be all y's or all m's, all right, as long as it's just one variable. Now, the degree of a polynomial function is the largest power of x that occurs, all right? So number 1, 2, and 3. We're going to just kind of determine whether these are polynomial functions or not based on the couple rules from up above. All right, so number 1, it says y equals 5x squared minus 13x to the 5th plus 20. In fact, I'm going to erase this power of 5, and I'm going to make that an 8, just so there's no confusion. With I want all my digits to be different. All right, okay, let's get rolling here. Number 1, y equals 5x squared minus 13x to the 8th plus 20. All right, notice the coefficients on your x terms. They are real numbers, all right? So far, so good. And then you're going to look at the powers on your x variable. You got x to the 2nd power, you have x to the 8th power. And those are both non-negative integers. So this is a polynomial function. Now, what degree is it? It's the highest power that you see on your x. So this would be of degree 8, right? So this is an 8th degree polynomial function. All right, so let's do this. This is a polynomial function. Let's abbreviate. And we'll say it has a degree of 8. Okay, let's take a look at number 2. We have f of x equals the square root of x. Well, we could rewrite this, right, as x to the 1/2 power, if you remember that from Algebra 2 or Algebra 1. And you take a look at that power, and it's a fraction. It's not an integer, and it's not a non-negative integer. So this is not a polynomial function. And last but not least, we have number 3. We have g of x equals 2 times x to the 3rd over 5 times x to the 7th. Well, if you take a look at the powers there, x to the 3rd over x to the 7th, this is ultimately x to the negative 4th power, right? Or x to the positive 4th down low if you reduced. All right, so that x to the negative 4, the negative 4 is also not a non-negative integer. It's a negative integer, but not a non-negative integer. So this is not a polynomial function. Now these could be functions, right? Just not polynomial functions specifically. All right, let's move on to another topic.